Hi, welcome. This is a lesson on properties of exponents. And to get us started, we often write b to the x to help us remember the number, the big number down below is called the base. And the x, the small number that comes up and to the right of that number, is called the exponent. And the exponent tells you how many times that the base is multiplied, or how many times it's a factor. So I'm going to skip around here just a little bit on these properties. If you go down to the bottom one, or not a bottom one, but this x to the m times x to the n, when we multiply like bases, we add the exponent. So that's equal to x to the m plus n. And if you look at it like real quick, I'll give you an example. If I have 2 squared times 2 to the third power, and I remember that 2 squared is the same as 2 times 2, and 2 cubed is the same as 2 times 2 times 2. Here you can see that 2 is being multiplied by itself 5 times. And so that's the same as 2 to the 2 plus 3 power, and 2 plus 3 is 5. And so that would be the final answer. Unless you wanted to go ahead and evaluate that when you can. You can't always, but you can with a number. 2 to the 5th power is equal to 32. It's 2 times 2 times 2 times 2, and that's 32. All right. So if we get x to the 7th times x to the third power, that's x to the 7 plus 3, or x to the 10th power. And it works with fractional exponents as well. If you have 4 squared times 4 to the 1/2 power, that's 4 to the 2 plus 1/2. And you could write that as 2.5, or you can write it as an improper fraction. 2 is 4 halves plus 1/2. That'd be 4 to the 5 halves power. Or, like I said, you could write that as a decimal exponent. That'd be 5 to the 2.5 power, and that would work as well. All right, and when you divide like bases, you subtract the exponents. So that's x to the m minus n. And some examples here. If we got y to the 12th power over y to the 9th power, that's y to the 12 minus 9, or y to the third power, or y cubed. When you have more than one term there, excuse me, you do it with just the like basis. So this is 4 to the 8 minus 3, and x to the 5 minus 3. And then we want to simplify that to 4 to the 5th power, and x to the 2nd power. And like I said, you could take 4 to the 5th power and say, what is 4 to the 5th power? On our calculator, that would look like 4. We use this raised to the power 5, 4 to the 5th power, and then hit enter, and we see that it's 1024. So we could also write our final answer here as 1024x squared. And either of those may be acceptable answers. You just need to ask your teacher which they prefer. So now we've looked at division and we subtract the exponents, then we make more sense of these next couple of properties. X to the 0, x to the 0 is 1. Let's see sort of why that is. If you had 2 to the third power over 2 to the third power, we know that when we divide like bases, we subtract the exponents. So that's 2 to the 3 minus 3, which is 2 to the 0. But on the other side of that, 2 cubed is 2 times 2 times 2, or 8, and it's the same down in the bottom. And when you divide a number by itself, and you divide a number by itself, you get 1. There is an important thing to note, that x, the base, cannot be equal to 0. All right, so here I've got this big number here. Let's see, it's 1,234,567,890 raised to the 0 power is 1. 64x squared y to the 63rd power z raised to the 0, all raised to the 0 power, because it's all in parentheses. This is also 1. Again, worth noting that x cannot be equal to 0, y cannot be equal to 0, and z cannot be equal to 0. And so long as none of those are equal to 0, then this is true. All right. Negative exponents. Well, if you have x to the minus n, that's equal to 1 over x to the n. Once again, if we go back and look at a quick example here, if I have 2 squared over 2 to the 5th power, that's 2 times 2. Oops, let's make that a little better. 2 times 2 over 2 times 2 times 2 times 2 times 2, 5 times. And this 2 cancels this 2, because 2 divided by 2 is 1. 2 divided by 2 is 1, so it leaves a 1 up here in the numerator, excuse me. And in the denominator, it's 2 times 2 times 2, or 1 over 2 to the 3rd power. But I could also say this is 2 to the 2 minus 5 power, and 2 to the 2 minus 5 power is 2 to the negative 3rd power. Once again, we see that if you have a negative exponent, it becomes positive when it switches into the denominator. Unless you have a negative exponent in the denominator, then it becomes positive when you switch it up. And I think that's what we're going to see in the next example. X to the minus 7, 1 over x to the 7th. It, again, important to note that x cannot be equal to 0. And 3 to the minus 4 is 1 over 3 to the 4th power, which we can evaluate 3 to the 4th power as 3 times 3 times 3 times 3, 4 times. So that would be 1 over 81. And there's no way 3 can be 0, because 3 is 3. So we don't need to say that like we did up in the above example. All right. What happens when you have a negative exponent down in the denominator? Well, it becomes positive up in the numerator. So that's 1 over x to the negative n is 1 over x to the n. You could think of it as 1 over x to the n over 1, but dividing by 1 doesn't change it any, so we typically don't write that. But if it's negative on the bottom, it becomes positive in the top. So let's look at some examples here. 1 over y to the minus 3 is y to the 3rd power. And 1 over 4 to the negative 2/5 power is just 4 to the 2/5 power. All right, see where we're at here. What happens when you have a power of a power? Well, what you do is you multiply the powers. That's x to the m n power. Remember that this means m times n. When you just have two variables right by each other, that's what that means. Mn is m times n. And then why is that the case? Again, if you use a quick example here, if I put 2 squared and raise it to the 3rd power, this power 3 means that the parentheses, what's in the parentheses, is multiplied by itself 3 times. So I could rewrite this as 2 squared times 2 squared times 2 squared. And then if I expand those out, each 2 squared is 2 times 2. So I've got 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 6th power, which is the same as what we would get if we just took the 2 times the 3, 2 to the 6th power. And that's when you have a power of a power. Keep that separate from this rule here. It says when I multiply like bases, I add the exponents. When you have power raised to a power, you multiply the exponents. So 7 to the second power raised to the third power is 7 to the sixth power, because 2 times 3 is 6. So 7 to the sixth power, let's go ahead and look at that. 7 raised to the sixth power is a pretty big number. Let's see how big it is. It's 117,649. 117,649. Then we've got x to the, or 8 to the 1/3 power. Here, there are two parts, and so each of them that are multiplied get raised to this power 1/3. And so that's 8 to the 1/3 power, and x, 2 times 1/3 would be 2/3. And so that would be our answer. You can actually simplify 8 to the 1/3 if you wanted to look at that. Let's go ahead and see it. 8 raised to the power 1. Let's made a mistake there. Delete. 1 divide by 3, and then I hit enter, and it's 2. Okay. But 8 to the 1/3 would be fine. I would have accepted that answer from most of my students. So then you can write that 8 to the 1/3 is 2, x to the 2/3 power, and either of those would be acceptable. All right. Then we've got x over y, all raised to the m power. Well, that's each of them raised to the n power. So x to the m over y to the m power. So look at this example here. This is 3 to the second power over 4 to the second power. And both of those can be evaluated. So this is 3 times 3, which is 9, over 4 times 4, which is 16. And that would be my final answer. When you've got a negative, the same thing applies. We'd write 10 to the minus 2 power and x to the minus 2 power. And typically we want to leave our answer in positive exponents. And so the negative comes up positive, and the negative here comes down positive. And so this just switches x squared over 10 squared. And because we can write 10 squared as a number, we can write this as x squared over 10 times 10, 100. And that would be our final answer. That's what I've got for you today. Practice, practice, practice. You're going to do fine.